we start in the main interface of CST on the modeling ribbon and go to Import Export, 3D Files, and SAT file. And then I'm going to browse to the SAT CAD file. Open that, brings in these three objects. The list of these objects is shown in the component library at the top of the navigation tree. If I go to materials, some materials have also been imported, namely copper. You can see the characterization of copper here, and iron. Now the iron hasn't quite managed to bring in the characterization, so I'm going to open this and make the mu 1000. I could of course characterize this in much more depth. I could bring in a BH curve characterization. I could add in conductivity, that kind of thing, but I'm going to leave it with a mu of 1000. Okay, so now that the objects have been imported, I do need to set up the sources. So I'm going to go to the simulation ribbon at the top, and I'm going to have a magnet. This middle object here is a magnet, and two coils on the ends. So go to the permanent magnet here and click on the middle object, which brings up this window, and I'm going to change the orientation. Give it a remnant flux, and if you're wondering about any of these settings, you wanted to know more about the settings, you can press this help. Most of these windows that come up have help buttons which take you directly to the online help, and you can look through this, read through this to get a better idea of what all of the settings are for. Okay, so that's one of the sources, which is the permanent magnet, and the other source are two coils. But in order to do the coils, I need to set up a couple of curves. So to do that, I'm going to go back to the modeling ribbon at the top, and I'm going to switch on a local coordinate reference, because the local coordinate reference I can move around, and I need to move it around in order to draw a profile and a path for my coils. So I can use pick points. CST uses pick points to navigate structures. If I press P on my keyboard, it makes all of these different points available. And I go to this corner here, pick this point essentially, and I align the working coordinate system with that point. You'll also see that this plane has moved because we're going to be drawing on this plane. We're going to be using the curves here in the middle of the ribbon, and the curves are drawn on a 2D axis, the UV axis. I go to rectangle and roughly draw out what I'm thinking of doing. Okay, so I now have this as a profile. I do still need to create the path, which I'm also going to create with a rectangle. You could also use a circle or a polygon, but I'm going to use a rectangle. So the first thing I'm going to do is to move this UV plane up, and I'm going to rotate it around the v-axis. Sorry, around the u-axis rather. Okay, so this is where I'm going to create the path. So again, I'm going to go back to curves and rectangle and roughly draw out what I think is going to be the path, and within the window be more precise about what the path is going to be. It looks very close to what it needs to be. Okay, so now I have two rectangles. They're also over here in the navigation tree in the objects area under curves. So I go back to the simulation ribbon and click on coil. Within the window it says double click to select coil profile curve. So I'm going to select the first rectangle, and then it says double click to select coil path curve. There I select the second rectangle. Now it's built this curve, this coil for me, and opened a window for more settings. So here I can put in the current. I could even parameterize it if I wanted to. I'm going to give it 1,000 turns. I could also give it resistance. If you're interested in any of these settings, again, you can go to the help button. If I go OK, it doesn't know what current's supposed to be initially, so I'll give it a value. You can see down at the bottom, this parameterization has been captured in the parameter list. I don't have one curve, I have two curves, but instead of following that entire procedure again for the curve on the other end, what I'm going to do is use a transform here to mirror this coil over to the other end. But first of all, I'm going to move my local coordinate system to be in the middle of this gap. So I'm picking these 2 points. Then I mean those 2 points, so it's right in the middle of the gap. I align the coordinate system to that point, so it's in the middle of the structure. Now I can go to coil in the navigation tree. I can go to transform. Transform is a very useful feature. I'm copying something and I'm going to use mirror to do it. You can also scale things. You can copy things multiple times. You can rotate structures. There's a lot of different things you can do with this function, but right now I'm going to be using mirror to copy it. Now I'm mirroring in the direction of the y-axis. So this is the plane I create to mirror, and you can see the other coil in the other side of other end. Okay, I go OK, and now there are two coils shown, and they do have current going in opposite directions. One's clockwise, one's anti-clockwise, which is exactly what I'm looking for. Now on the simulation ribbon, there may be other settings that you want to change. You may want to consider what boundaries you need. I'm okay with electric here. I do want to create a bit more space around this though, so I'm able to capture and look at all of the fields around it. So I'm going to go to background, and it's 10 millimeters, so I'm going to change this to 20 just to give it a bit more space. I'm going to take a look at the meshing. Okay, the mesh is very coarse, so what I'm going to do, and there are very few mesh cells, there's only 1365 shown on the bottom right here. I'm going to increase this. It does have adaptive meshing, but it can take quite a long time to do adaptive meshing, and I don't want it to take a huge amount of time. It's still a very small amount of mesh cells, so I see no harm in actually increasing it more. Okay, this is looking pretty good. You can also take a look at the background. That's also looking pretty good. The last thing I'd like to do is I want to monitor forces, and to do that I'm going to have to create a monitor. So I'm going to, on the simulation ribbon, go to monitor on volume, and it's already selected. I'm going to see what forces are acting on the magnet, and you can see that monitor has shown up on the list on the left, the navigation tree. So at the top, just to quickly recap, we have the objects, we have the materials, any curves. In the middle are the sources and monitors, and once the simulation is run, the results will be at the bottom of this list, this navigation tree. Okay, I go to modeling, or rather home, and I go to this MS. This is the magnetostatic solver, and these are the magnetostatic solver settings. As I said, this adaptive mesh is on, so it will adaptively change the mesh to reach convergence. I could also here check these to create inductance matrices if I was interested in that result. Otherwise, I press start and the simulation runs. And how the simulation is running will be shown on the progress on the lower right hand side. There's also messages here which can give you an idea of how the simulation is running. Okay, so we go back to the navigation tree on the left. Let's first of all take a look at the fields. So these are the fields. In 3D, I can create a plane. I can also change this to different views to get an idea of the fields. Here's the H field. Now, to go to 1D results, here is the force results. It did do 2 passes, so it's showing you the results for both passes. They're very similar because the mesh is already close to convergence. So the absolute value shows you that the main force is in the X direction. So I'm going to go to X. So in the second pass, it was getting 3.81. So most of the force is within the X direction. You can also parameterize this and run parameter sweeps. So say you wanted to take this magnet and move it around and see what happened to the forces when you moved the magnet around. You could do that by using this parameter sweep within the solver settings. To move this around, I'm going to click on the magnet and go to back to modeling, back to transform, and I can say I wanted to move it around this way, I can call this something, distance, and I can give it a value. I think right now it's at 6. So and here, if I animate this parameter, so say I wanted to go between 0 and 6 in my parameter sweep, or maybe even -6. If we put the magnet through each of those paces, I'll animate that again. So I'll move the magnet like this, and it will take the results at each step, which I can then look at under post-processing. Post-processing is in this ribbon. So to set that up, I'll go to the statics and low frequency, calculate force and torque, and I'm going to select the magnet, and for this I could be interested, say, in the X direction, or I could set up multiple directions, and for each parameter it will execute this, and I can see how the force changes over this distance parameterization.